So I wanted to try and do this integral here. Let's go ahead and try it. So we have this integral from 0 to infinity log natural x squared plus 1 over x squared plus 1 with respect to x. So where should we go with this? Well, because we have like these the 0 to infinity thing, first thought is to introduce a parameter a. Oops. Log natural x squared times a squared. Would it be? I don't know why I would do that. Why not? Plus 1. Just to keep it symmetrical there. Well, we have this, so we can go ahead and track what would be at 1 to make sure we're doing this right. Yeah, we're doing it right. Okay. So now let's take the derivative with respect to a, which is I prime a. Let's call it I2a equals int to infinity log natural. Well, because it's in a log natural, we can just do what the log natural derivative is. So it's over x squared plus 1. That in parentheses, and the log natural derivatives is d over dx log natural. Like x squared plus 1 is just 2 over x squared plus 1, right? No. It's 2x. Yeah. So it's the derivative over the normal function. So yeah. It's inside the log natural. So we have 2a times x squared over the total thing, which is 2 a squared. No, there's no 2 there. A squared x squared plus 1. So we have this now. Okay. Oh, I hate doing this. 2a x squared is equal to 2a x squared. Oh my god. Okay. So yeah. I don't remember where to go from here. Cause like this stuff, like I'm not good at the like polynomial tricks, all that stuff. So let's just try and rewrite this in terms of like a polynomial like this. So that is 2ax squared divided by x squared plus 1 times a squared x squared plus 1. And this is identical to this here. Yeah. So, we can move on from here to 2a. It is a, right? Yeah, it's a. So, let's say we want to introduce something to where it'll simplify to where it'll be like a matching thing. Like, you want like to have something that like creates something similar to these. So, like 2a over a minus 1 or something. So you get x squared times a. Oh, it's. We're not doing the. Let's do a squared minus 1. So x squared minus x squared. And then now that we have this, you might be able to see a few patterns. So in this, we can do very cool technique, one that I hate, where you add 1 and subtract 1. So, in this, original 1, plus 1, minus 1. it's the same thing, but now you can group this in such a way to where it lines up with these. So this would just become, stop it, +1, and because grouping it's commutative anyways, so it's fine, it's the same thing. Yeah, we gotta make this +1. Yeah. So, this is the same as this. And we can just move through here. We can simplify this into something like, just, distribute these. So now everything's distributed, which means it can just become 2a over a squared minus 1 times 1 over x squared plus 1, because this term is the same as this term, they cancel out, so it just becomes 1 over x squared plus 1, and then minus, over here, the other one cancels out, so it's 1 over x squared, a squared. Figure it out. Okay, we have this now. Got that sorted. So, let's plug this back into the original thing, so this back in up here. So now, see, it's just this. To check if we're right, though, let's see if, it will probably be fine. It'll probably be fine. So this just becomes my enemy. Yeah, because, yeah, it lives up. Okay. Yeah. This becomes my enemy. It becomes trigonometry. We love trigonometry. Let's go. I don't really, I need to really work on my trigonometry stuff with, like, calculus. But this becomes pi over 2 minus pi over 2a. That's what those two things become. So the derivative equals 2a over a squared minus 1 pi over 2 pi over 2a minus pi over 2a. Now we gotta start sorting stuff around until it looks like something we can integrate properly with respect to x. We've already come a long way. This is a lot better than the beginning. So, let's see. I already see something here, so pi over 2a squared minus 1. And then minus 2a pi over 2a, so that just becomes pi. So okay, where am I at? Okay. So 2a minus 1 pi. Just say that. Okay. It wouldn't just be 1. It'd be 2a minus 2a squared minus 1. Okay. Yeah, because then it would cancel out. So that over 2a squared minus 1. That looks great. But I don't really think... Could we integrate those? Could do something with it. Okay. I think I know where to go with this. Okay. Pi 2a over 2a squared minus would still work the same, wouldn't it? So half of that is a distribute, and then minus pi. That can't be right. Oh, here she comes. If she doesn't interrupt me. Okay. This reminds me of a logarithmic form, but like, okay, let's just try it. Whoa, none of this stuff looks the same, by the way. No, it is the same. Okay. I6. Running on fumes. It's 1/2 pi minus pi. Okay. Minus pi a. Specifically. What's that? No. It's not right. Because, yeah, this one... Yeah, it looks completely different. That's not even the one we're supposed to be looking at, buddy. Yeah, this one looks completely different, so... I don't know where I'm going. I know where I'm supposed to go. Wait. Isn't that just this? Now what? That's another issue. Yeah, I did something wrong here. Oh. You're so stupid. Okay. Yeah, that's more like it. Go all the way back here now. What an idiot. So now that is... Oh, that's way easier said than that. She comes. What is going on? Oof. Oof, 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 oof. Wait, what? What am I... What? What am I doing? Yeah. Okay. So that's just 5n equals pi minus 2 minus pi squared minus 1. And now what? Wait, it's not 2, isn't it just 1? Wait. 2. What have I done? Yeah, that. Okay. Where do I go from here? Just factor pi out, I guess. E minus 1. Hey, we might be going somewhere. Okay. I remember something here. Is it having to do with like the factorization? Right! Isn't it because like a squared minus 1. So let's do a minus 1, a plus 1, and then we do like comes like a squared plus 1 plus a, actually, then minus a plus a squared. No, that's not what it is. And then there's a minus 1 in there. Let's see here. A squared plus a is just this to these two. So now we do the minus here. So minus a minus 1. Yeah, a squared minus 1. So we can factor that out. It just becomes a, over a plus 1. Yeah, that was the trick. That's the cool part there. Plus pi over a plus 1. So a equals pi. I don't know why I wrote it as pi over a plus 1. I could just write that as 1. And times pi because it makes it easier for integration, which we haven't done yet for a. So now we're going to integrate with respect to a. Equals pi log natural a plus 1. Didn't look at this notebook. I didn't look at it. I looked at it for a few seconds, but that was only for the factorization. I didn't see it though. I didn't see the factorization on there. This doesn't have a script or anything either, so just math stuff. That's actually what gave me the idea to do this video, is me seeing that. So let's just I8 1. We get the same number, but just to check that, we get pi log natural 1 plus 1 pi log natural 2, which is just that. Okay. This is... it's probably the hardest integral I've done. Just because, like, the Feynman trick, like the integration under the integral sign, it does something, but, like, the issue is just always, like, the polynomial stuff. Like, I just gotta get more used to doing that stuff. I'm glad I was able to do this like this, though. That was pretty cool. I'm happy about that. Not very explanatory video here, but just me going through it here. Plus, it's just something for me to pass the time as well, because, you know, there's not much to do. You know, school's coming up in 30 days, and I can't wait for that. A lot of stuff that I've been working on, planning for whenever I get back in school, which will be 10th grade. I'm entering 10th grade. We're getting there. I can't wait until I get there. But thank you for watching. Again, this is the integrated version of I7. It's integrated, so that's why it's like that. I want to make that clear now, because I didn't really write any of that out very clearly. But so we know that this, we can turn that equal to just log natural a plus 1 pi. This can become this. You know, strictly for positive, because it doesn't work for the negative one of this type. But we don't need it to, though, because we're only looking for a equals 1 from, for this one. We're just plugging in a there. So we were never going to go for a negative number, so that's fine. Thank you for watching. Bye. If you want, you can watch some of my other videos. Helps me out. I'm not really doing this for engagement, really, but that just, it's cool if that could be a thing. Thank you for watching, and bye.